Hi guys. All right, now let me walk you through the water level control part 5. This one is our water level control part 5. Remember, I started from part 1. Okay, so if you're not able to capture those videos, you can now go to my YouTube channel. Here is the link, YouTube channel. So you can now go and watch from part 1 to part 5 so that you will understand the process from the scratch. Okay. All right, so the previous exercise, we are able to demonstrate how you can control water system, water level control using schematic design. Meanwhile, here is going to be ladder diagram. This is ladder design, ladder logic. Like I told you before, we are going to convert schematic, and this is what we did to convert schematic. Let me see if I can get the schematic. All right, so here is the schematic, the previous exercise. We are able to use this schematic diagram to control water level. All right, and I told you that we're going to convert this schematic to ladder logic, and here is it. Let's see if we can reconcile the two. All right, remember I told you that this is just an introductory part of this particular segment. If you actually want to go deep into the career, then you contact me through this number. I will give you 5 days intensive training that will walk you through the starting from the scratch to the finishing, from scratch to advance, on how you can put up a design using schematic logic, schematic symbols, and they also use ladder diagram. Okay. All right. Now let's reconcile the two different design. This particular portion, like I told you before, is the starting uh, logic. This portion now here is the initial, for you to initiate the command of the operation. This particular logic is responsible for that. Then this other two logic here is responsible for controlling the water flow and the filling and drilling. Filling and drilling. When it is filling, this network will be energized. When it is drilling, this other network will be energized. Okay, the same way here is for you to initiate the sequence of operation. Then this first one is for you to feed the water into the tank. Then this other network is responsible for drilling the water out of the tank. All right, so let's put off this particular previous exercise and illustrate and simulate this water level control part 5. All right, the concept remains that we're going to familiarize ourselves with design before we go into automation career. This is one of the logic control system. This is a schematic for a control system of a sequential controlling of a particular process. This is the machine that I want to control using this control schematic. Okay, this is our power circuit and this is our control circuit. So these processes will enable you know how to synchronize symbols, understand the function of symbols, understand how they works, and use them to control a particular process. Okay, so don't look at it like this and feel that it's complex. No, you must start from a symbol, just particular symbol. You must understand this symbol and know the function of this symbol and know when to use this symbol, and you understand this one again. That is how you know how all of them works, and before you now start synchronizing them to perform a particular task. Okay, all right, so by the time you go to advance, you must have gone through the process and the concept on how to design a complex system. Okay, you know the whole of this. These are the requirements before you go into automation. Like I said before, you must know design, know how to design, how to read drawings, how to interpret drawings, okay, and how to carry out the installation, terminate the cable from point to point, and also how to terminate your installation cables of your PLC, all right, and how to terminate the field instrument. Okay, these are the first process. After that, you now come into automation system for you to write a program, because the idea is this: when you understand the control system is your ability to design a hardwire control using component, real life component. and wire them and build a control panel and use that particular control panel to monitor and control a process. Use it to control equipment, use it to control a machineries. Okay, now PLC and automation come into play because you want more efficient method of controlling that process. All right. Okay, automation will not teach you design. Automation is advancement of control. For you to control a particular process using the more innovative method, using the more cost efficient method, using the uh, uh, more precise method of controlling a process. All right. Instead of you to use more component of hardwire component, you use 60% of your device is going to be controlled by a software. So your physical component will be limited. All right. Okay. Because software, we have a lot of functions and features that is going to be responsible and dedicate some function to them so that the field instrument and the physical actual representation of component that is going to be used will be limited. Okay, 70% of the fixtures that are going to be used for operation, PLC has them embedded in the device PLC. Okay, like to minimize the use of physical components. All right. Okay, so if you have that particular concept, in that case, you must understand the functions of those devices. All right. So that is why I take you to control system before I will take you to automation. That is the essence of this particular page to teach you, familiarize you with control system before you now go into automation. All right. If that is carried, we can now minimize this, then come back to our subject issue. All right. So now let's simulate. Let's, like I said before, if you are a little bit confused about this design, you can now go to chapter 1, part 1 to start watching from part 1. Or alternatively, contact me from this, come to my YouTube channel and send me a request for the training. Then I will give you a comprehensive, intensive training for within few days so that you familiarize yourself on how to use this, okay, and how to put up design such as this. All right, so let's design, let's simulate. Okay, I'll put on my simulating function for this particular ladder logic. I'll also put on my graphic simulation. Okay, all right. Let's simulate now. The function is going to, the sequence operation is going to go this way. If I initiate command on this pump will come up, now pumping water to the tank. When the water fill, starting from the bottom and come to this sensor low level switch, there is LLS. When it come here, this one will get activated. When this one is activated, the water still keep pumping. The water will keep pumping until you come to the high level sensor, the upper one. When you come to this other one, this one will also get activated. When this one get activated, it will now send a signal to the ladder, telling the ladder that the water is at the maximum point. Okay, then this one will get activated simultaneously. Once this one gets to sense the presence of water, as this one get activated, it will now activate this one for this one to start drilling. All right. Okay, let me put up a narrative. Okay, let me use a narrative to put you through. Now we have a water process factory or a liquid and processing. I have a reservoir. I have a very big tank that I store. It's my storage tank that is in charge of accommodating the product, the liquid, or the water that I want to use for my operation. It's going to be a very big tank. Now that tank is where my storage is going to be. Then this other tank is going to interface between the storage and my production tank. Production tank is going to be this. Then storage tank is where my fluid is going to be stored. So each of my operation is going to rely on this tank. So the operation for the day It's going to be working with my day tank. Let me call this one day tank. So the product coming from here is coming from my storage tank to fill my day tank. So my day tank is the capacity that will accommodate whatever production that is going to be taking place per day. Okay, I'm giving you just a scenario so that you understand this. So when the operation commences, from the reserve tank, water will move to fill this day tank. Okay, this day tank is going to help us to calculate the volume of liquid or the volume of water that we have exhaust in a day, because this one is already calibrated. Supposing I have this tank, let me shut down this. Just hold on. Just hold on. Let's shut down and finish this description. Okay, supposing I have this tank to be 20,000 liters. Supposing I have it to be 20,000 liters. If this tank is going to be 20,000 liters, okay, okay, the capacity of this tank is 20,000 liters. All right. The essence of interfacing, creating a day tank for the operation is because I want to keep account of my production per day. Although I have other fixtures, other devices, and the counter that is going to be responsible for counting the products produced or the item produced per day. But I'm not going to rely on those devices. I will also rely on about two different means of calculating my production per day. Should in case if there is a variance or fail in production and those devices fail to give me a precise value. So I can use this day tank to determine how many that is going to produce. If this is 20 liter, 20,000 liters, how long did this finish in a day? If I was able to finish to empty this tank up to 5 times a day, so I can now evaluate my consumption or my production by 20,000 times the number of times then this tank was empty. Okay, I just give a scenario. Okay, all right. So that is the essence of this. So I have another storage tank where this pump is pumping from. But this one now is going to my finished product production. That's this one that's drilling. Is going to another process line to produce that liquid or to produce whatever thing I'm working with. All right. So I think this narrative will be enough for you to capture the operation sequence of what I'm about to present to you. So now let's simulate. All right. Put on this as well. Okay, so let's simulate now. I will initiate the command by pressing my button on my HMI panel. Okay, I press button here. Water start filling. Look at this one. This one is activated because water is now sense water. It will get activated. Water keep moving. When you come to this area, look at this one. This one get activated again. Simultaneously, when this one get activated, it will shut down this pump. It will shut down this filling pump. This one will shut down. Look at water is no longer going or fluid is no longer going. When this one shut down, this one will open and start drilling. So both of them work on a circular mode. When this one is active, this one is inactive. When this one is active, this one is inactive. So both of them alternate the operation. Look at the valve open. It's now drilling. This one has shut down. Okay, so that is the operation sequence of this water control. All right, so the whole of this narrative is to familiarize you with what we call control system concept. Okay, let me shut down. Let me shut down. All right, now for you, the ability for you to know how to design this and use logic such as this to control water. This one is to enable you know the a kind of as built design. When you go to the site, this is similar thing that you're going to be in place. Okay, so this is visually what you're going to see at site when you go to site and you have this. If you have this and you don't have this, you may be wondering what is work of this. By the time I simulate this, let me simulate. By the time I simulate this, this one is just going up and down, displaying on and off, on and off. and no utilization of the operation such as this, you will find it difficult to capture whatever program that you are writing. Okay, so after this sequence, I will take you to Siemens Tier Portal. There's another software called Factory IO. Okay, Factory IO is the graphic software that will also show you the representation of a operation view, operational graphic of what the ladder logic is controlling. Okay, all right. Okay, thank you. So the next stage now is to use a PLC. Okay, to connect the whole of this device, you are going to connect them to PLC. That's the next level now. So we're going to display a PLC device and they run our cable from the whole of this to PLC control. Right? Okay, thank you.